So when we simplify square roots, okay, well, let's just talk about what a square root is. Okay, a square root is a number that when multiplied by itself results in the number that appears under the square root symbol. Blah. Okay, so here's what we know. All right, so if I were to take, say, 2 squared is equal to 4, all right, and what that means when I do 2 squared, remember that's 2 times 2 is equal to 4, okay? So when we take the square root of 2, or square root of 4, it gives us 2, all right? And so what we try to figure out is, you know, what 2 numbers multiplied by itself gives me 4, okay? So that's the question that I ask, and I'm going to write that up here. So a square root, and I'm going to say I ask the question, all right? Ask myself the question, what two numbers multiplied by itself gives me the radicand, okay? And the radicand is the number. All right, so then that's another word we need to describe. The radicand is the number underneath the square root symbol. Okay, and so that's what we're doing. Okay, so you know, if you were to take the square root of 9, it would be 3. And the reason why is because if I take 3 squared, it's equal to 9. So 3 times 3 is equal to 9. Therefore, the square root of 9 is equal to 3. Okay? And so, let's just go ahead and take a look at this. And it says find the square roots. Okay? And so when I look at this and I say, okay, what's the square root of 16? And that's just going to be, it's just going to be 4. Okay, and the reason why is because 4 times 4 is equal to 16. Okay, so 4 squared is equal to 16, and so the square root is going to be, the square root of 16 is going to be 4. All right, let's take a look at the next one. The next one says, what's the square root of negative 25? Okay, this is really has a non-real solution. Okay, in Algebra 2, we're able to actually evaluate this, but we can't actually evaluate this under the square root symbol. Okay, and here's the reason why. If I take 5 times 5, that gives me a value of 25. Okay, so if I take a number and multiply it by itself, it's going to give me a positive number. Okay. Even if I were to take, say, negative 5 times negative 5, I'm still going to get positive 25, okay? So the rule of thumb here, okay, what we need to remember is that we can't take the square root, can't take the square root of a negative number. Okay, and so we're restricted. Okay, we can't do this. Okay, we don't get a real solution. There will be a point at which you'll do that in Algebra 2, but let's not worry about that now. Okay, so so that's kind of the idea, all right, of a square root. Now, before we go on, well, when we talk about simplifying, let's just talk about some properties of square roots. Okay, the one thing I can do with square roots is I can take a square root and split it up into the product of numbers. Okay, so let's kind of take a look at an example here. Let's just say that I'm taking the square root of 50. Okay, and when I look at the square root of 50, what I can really do here is I can split this up into the product of 2 numbers, okay? And let's just say that I rewrite this as the square root of 2 times 25, okay? what I can then do, because I'm taking, all I did was rewrite the square root of 50 as the square root of 2 times 25. If I take 2 times 25, that's going to give me 50. All right, but if I continue this, then what happens is I can take the square root of 2 times the square root of 25, okay? Provided that these numbers are positive, and that's what that means, is that when for a is greater than or equal to 0 and b is greater than or equal to 0. So what I can do here, all right, I can evaluate the square root of 25. Okay, that gives me 5, all right? So 5 times the square root of 2 can be simplified. Okay, so I can take the product of those two, all right, and do that. All right. The other thing I can do is I can do the quotient property of square roots, okay? And so let's say that I have a fraction. Let's say I have a fraction of the square root of 4/9, okay? And what I can do is I can split that up, and I can take the square root of my numerator, which is 4, and I can take the square root of my denominator, which is 9, okay? And the square root of 4 is going to give me 2, and the square root of 9 is going to give me 3, okay? So you can simplify them that way as well, all right? What I want to do is talk about simplifying the square root expressions, okay? And kind of like what I did over here, all right? Now, before I do that, I want to talk about perfect squares, all right? And I want you guys to write out this list because we're going to come back to this list. So this is a list of perfect squares, all right? And I'll tell you what I mean by perfect squares. And so, look, okay, what I've got, if I take 1 squared, that's going to give me 1. Therefore, if I take the square root of 1, I'm going to get 1. Okay, if I take 2 squared, that's going to give me 4. If I take the square root of 4, I get 2. Okay, I'm going to do 3 squared is equal to 9. Therefore, the square root of 9 is equal to 3. Okay, if I take this 4 squared, it's going to give me 16, and then if I take the square root of 16, it's going to give me 4. All right, if I do 5 squared, we get 25, and then if I take the square root of 25, I'm going to get 5. Okay, 6 squared is 36, so the square root of 36 is equal to 6. If I do 7 squared, that's going to give me 49, and the square root of 49 is equal to 7. 8 squared is going to give me 64. Square root of 64 is equal to 8. 9 squared is equal to 81. So then the square root of 81 is equal to 9. Okay, let's keep going. If I do, say, 10 squared, it's going to give me 100. So the square root of 100 is equal to 10. 11 squared is equal to 121. So the square root of 121 is equal to 11. All right, if I do 12 squared, I get 144. Square root of 144 is going to give me 12. 13 squared is going to give me 169. So the square root of 169 is equal to 13. 14 squared is going to give me 196. So the square root of 196 is equal to 14. And then let's stop at 15. 15 squared, I want to say, is 225. Let me double check that, though. And it is. 15 squared is going to give me 225. So then the square root of 225 is equal to 15. Okay, and so here's the deal. All right, here's the reason why I wrote out all these numbers. When we're simplifying square roots, what I want you to do is think of all of these numbers here. Okay, 1, 4, 9, 16, 25, 24, I'm sorry, 36, 49, 64, 81, 100, 121, all these numbers. These are perfect squares, okay? And so what I'm going to do is when I simplify, and these are numbers to memorize, okay? You need to know what these numbers are and what their square roots are, okay? You can regenerate this list if you want to help, but, have this list there to help you while you're going through this, okay? And so, you know, and that's the same kind of thing I did here, okay? When I took the square root of 50, I said, okay, if I take 50, what perfect square goes into 50? How could I split up the 50 into the product of a number and a perfect square? Because 50 is not a perfect square. And I said, okay, well, I know that 25 is a perfect square. And if I take 25 times 2, I get 50. So therefore, if I took the square root of 2 times the square root of 25, I could evaluate the square root of 25 and give me 5. All right. So then what I want to do is come over here and simplify the expression 225. Now, what I know about the square root of 225 is that it's just going to give me 15, okay? And the reason why is because I knew it was a perfect square, okay? And that's all I need to do. All right, so let's go back and let's take a look at another one, okay? And if I wanted to say simplify the expression of the square root of 81 over the square root of 121, what I would do is I'm going to take this, rewrite this as the square root of 81 divided by the square root of 121. Okay, the square root of 81 is going to give me 9, and the square root of 121 is going to give me 11. So this simplifies down to 9/11ths. So, you know, the reality of it is if I take the square root of 81 over 121, that's the same thing as me writing 9 over 11. These two things are equal. Okay, so what we got on the next page. Okay, on this next page, what I want to do is simplify square root expressions with variables, okay? Now, let's think about something before we do this. What I know is that, you know, we know that if we take, say, a number like 2 squared, that's going to give us 4. So therefore, if I take, you know, 4 and take the square root of that, it's just going to give me 2. So if I apply the same concept to variables, okay, and I say, all right, well, if I take x times x, that's going to give me x squared. Okay, x squared is just x squared. It's just x times x. But if I take the square root of x squared, okay, the square root of x squared is going to give me just an x. Okay, so now what I'm going to do is simplify this expression. Okay, and I'm going to split this up. Okay, and I am going to do the square root of, I'm going to rewrite this as the square root of 4 times x squared times x squared times x squared times x squared. Okay, and so what I know is that if I take x squared, okay, and I can split this up into the product of different x squareds. And when I multiply these x squareds together, I add my exponents, okay? And so what I do is, as I rewrite this and I say, okay, well, I can rewrite this now as the square root of 4 times the square root of x squared times the square root of x squared times the square root of x squared times the square root of x squared, okay? And so then what happens is I can evaluate all of these square roots. Okay, the square root of 4 is going to give me 2. Square root of x squared is going to give me an x, so times an x. The square root of x squared is going to give me another x. The square root of x squared gives me an x. And the square root of x squared gives me an x. Okay, so then I have 2, all right? But then if I'm multiplying, you know, 4 of these x's together, that's going to give me x to the 4th, okay? So what I know now is that if I were to take, say, the square root of 4x to the 8th, that would give me 2x to the 4th, okay? Now, one thing you may realize here is that, you know, there's a pattern here. Okay, if I were to say x to the 8th power, and I take the square root of that, that gets halved when I do that, okay? Because really what I'm doing here, guys, is I'm doing, when you take the square root of a number x, okay, let me write this up here, okay? If you were to take x, you know, the square root of x, that's the same thing as me taking x to the 1/2 power, okay? And that's why this part up here works. Okay, that's why that happens, that we get x out of this. Okay, so if I were to have, say, the square root of x squared, really what I'm doing is I'm taking x squared and I'm raising it to the 1/2 power. And when I have x squared raised to the 1/2 power, I multiply my exponents. When I have a power raised to a power, I multiply. And so then that just gives me x to the 2/1 times 1/2 power, which when you take, and that's just going to give me x to the 2/2 power, which is just x to the first, okay, which is just going to give me x, all right? So, I mean, rule of thumb, square root of x squared is just going to give you x, all right? But there's reasons why that happens, okay? And this up here is the reason why. All right, now let's go ahead and simplify this one. And even though we don't have an x, we have an r, it's the same property. So what I'm going to do is I'm going to split this up and I'm going to say, okay, if I take the square root of 64 times r to the 8th, then that's going to give me the square root of 64 times, and let's do this. I'm going to extend it out. I'm going to do r squared times r squared times r squared times r squared. Okay, 2 plus 2 plus 2 plus 2 gives me 8, all right? So then what I'm going to do is rewrite this as separate radicals. Okay, square root of 64 times the square root of r squared times the square root of r squared times the square root of r squared times the square root of r squared. So then square root of 64 is going to give me 8, and then all of these are going to reduce down to r, okay, or simplify to r, and so then I get 8 r to the 4th. Okay, so same property, same thing here happened as it did over here. All right. So now let's apply this concept of a square root and apply it to the idea that we have a square root function. Okay. And so what that means, the square root function, first of all, here is the square root function. Here's f of x is equal to the square root of x. Okay. Now notice real quick that this orange graph stops at 0, 0, and is only positive x values and positive y values, okay? The reason why, okay, is because my domain of this function, of a square root function, goes from, x values that are greater than or equal to 0. Okay, consequently, the same thing happens with your range, all right? Your range, you get y values that are just greater than or equal to 0. Okay, so we can't take the square root of a negative number, so I can't plug in negative numbers here, okay? We can manipulate this so we can reflect it over the y-axis and reflect it over the x-axis, but let's go ahead and, just see what happens here. All right, so what I get, let's just plug in, say, numbers like, like 0, 1, 2, 3, and 4, okay? Now, if I were to plug in 0, the square root of 0, two numbers that multiply together to give you 0 is just going to be 0, all right? So we get 0. Now, the square root of 1, okay, is going to give us 1. The number is going to go there. Okay, if I take the square root of 2, I don't know what that is, okay? That's just good, and you can evaluate that in the calculator. I believe it's like 1.41 something, okay, and the number keeps going. Okay, same thing with the square root of 3. I can't evaluate the square root of 3, all right? The square root of 3, two numbers that multiply by themselves to give you 3, they don't have whole numbers, okay? So I'm just going to leave this as the square root of 2, and I'm going to leave this as the square root of 3. Okay, this number is like, I believe, 1.7 something. Yeah, and it's about 1, and these are approximations. These are about 1.73, okay? But then if I take the square root of 4, that's going to give me 2, okay? So this gives me 2. So these numbers here are between 1 and 2, all right? So now let's go ahead and just plot these points here. And so you get the point 0, 0, you get the point 1, 1, and then you get the point 4, 2, okay? Now, the other number that you can take the square root of is 9, okay? So the square root of 9 is going to give you 3, okay? So if your x value is 9, all right, then, here's 9, here's 3, plot a point, and you have another point here, okay? So you get this general shape, and I call it the eyebrow, all right? And if I just draw a general square root function, you know, here's my function, I just do one of those, all right? And that's how it looks. And so, you know, that's all I'm doing, all right? So that's the idea of that, and that's how we get that graph, all right? So let's think about what happens if we reflect these graphs. Now, what happens is that, you know, if I were to have a negative sign out here, okay, if you have a negative sign out front, okay, it reflects it over the x-axis. Okay, but if you have a negative sign on the inside of the radical, okay, then it reflects over the y-axis. Okay, and here's the reason why. You know, if I were to plug in, say, you know, if I had f of x is, or let's not do f of x, let's do g of x. Oops. G of x is equal to, say, negative square root of x. You know, if I plug in, say, 4 for that, if I find g of 4, then that's negative square root of 4. Now, I evaluate that, and really what you're doing here, guys, is, you know, you've got negative 1 times the square root of 4. So then you take negative 1 times 2, which gives you a value of negative 2, and that's what puts that point down there. Okay? Now, if I came over here and I said, all right, well, let's look at h of x. You know, h of x is equal to the square root of negative x. Then, you know, if I were to find, say, h of 1, okay, h of 1, if x is 1, then I get to have the square root of negative 1. And this I cannot evaluate, okay? This has no answer. This is no real solution. All right, so there's no real solution, all right? But if I were to say, well, what about if I take, you know, h of, say, negative 4, okay? Then what I do is I plug that into my function here, and I get negative 4. Well, if I take, you know, negative 1 times negative 4, opposite of negative 4, that's just going to give me positive 4, which gives me 2, okay? And that's how you get this value right there, all right? And that's how that works, all right? So I hope you guys enjoyed this video. I know it's kind of a tricky subject, you know, and once you watch this video, work on the assignment, and if you have questions, let me know. I'm available to help. Okay, see ya. Bye!